Welcome guys, this is the 18.2 flip for environmental science. So 18.2 is all about hydropower and ocean power, so using water to create electricity. So currently you see on the screen there 19% of the world's electricity is made using water. So first let's look at a little bit of how that works. Like I've said many times, it's all about turning a turbine. So there are two approaches. You see here the hydroelectric dam model. Water comes in, turns a wheel, goes out. That's going to require a reservoir behind it. We've got several of those here in central Indiana. Raccoon Lake is a reservoir that's been formed from damming up a river. Mississinawa in northern Indiana is another example. The other type of approach is to use naturally flowing water. So you can use a river's current, or you can use tides, things along those lines. Anything where the water is naturally moving so we don't have to physically move it ourselves. Of course, anytime you're relying on natural processes, there's going to be variable supplies. Sometimes a drought is going to make a river slow down, or a flood would make it speed up. The tides are a bit more consistent, but still have some variability. So benefits of hydropower: completely renewable. We're not going to run out of water. We may run out of fresh water. But it is completely renewable. There's no air pollution, and it yields really cheap electricity once we get it up and running. Now, there are some pretty big costs, especially relating to dams. They're going to alter ecosystems. They're going to affect organisms. Think about things like salmon that migrate up streams and up rivers. That's going to mess with their migration pattern. We're also going to have to flood an area behind the dam to make a big reservoir, and that is going to take away ecosystems and habitats for maybe forest-dwelling animals, maybe grassland-dwelling animals, something like that. The dams are going to keep the silt or the sediment from being washed downstream, so it's possible that a dam would hurt farm ground hundreds of miles away. And then building the dam can displace people. Again, if you flood someone's home, they can't live there, obviously. And building the dam takes a lot of carbon dioxide, so it's not the construction of a dam still is costly in terms of the environment. Getting back to tidal energy, essentially that's using nature's tidal flows to push turbines. Might be in a dam, might be like the drawing I put on the board the one day. Generates little to no pollution. The best places to have tidal energy are going to have big difference in the heights of high tide and low tide. Some of the beaches, like near South Carolina, you can't. It's a small difference between high tide and low tide, maybe like a 10-foot difference. In other places, it's much greater. You see here in this picture the difference between the high tide and the low tide. It's pretty significant. Again, generates no pollutions, but shore ecosystems can be adversely affected because you've got to anchor it somewhere, especially if you're going to use like a dam type of model that can mess with coastal ecosystems, and those tend to be really important. Last type of hydropower we'll discuss is thermal energy from the oceans. The ocean absorbs solar energy and stores it as heat. You've probably experienced that if you've been to the ocean in the summer versus going to the ocean on spring break. Ocean is a little bit warmer in the summer. Ocean thermal energy conversion, or we call that OTEC for short, takes that heat energy and converts it to electricity. Basically, we're going to use warm ocean water to boil liquids with a very low boiling point to make steam or make vapors, and that's going to turn a turbine. Don't forget, it's all about turning a turbine. Check out this data point over here. The heat content absorbed every day by tropical oceans is equivalent to the content of 250 million barrels of oil. So it's not a small amount of energy that we're talking about here. Currently under development, it's not used today. One of the many theoretical things that could come in your lifetime. So that's 18.2.